I'm Geoff McQuilkin. I'm the Executive Director at the Mono Lake Committee. More importantly, I'm Kaylin's dad, as David said. Very proud of her. I'm going to talk a little bit today about Mono Lake in the era of climate change. Now, I get to do a lot of presentations about Mono Lake, and great. So yeah, I do get to do a lot of Mono Lake presentations. This one's a little bit different, I have to say. I'm often at conferences maybe telling the story of Mono Lake, you know, an uplifting story of public action and success and changing water rights and protecting the lake. I'm always happy to talk about that. We have challenges at Mono Lake, but sometimes, you know, we're even ahead of other locations. Climate change puts a little different spin on things, and often forces us to think about some hard Mono Lake questions. You know, what does the future hold over 20, 40, 80 years as we try to implement all these protections we've won and get the lake up to its management level and so on. So I do not have all the answers for that. I will have some questions. I hopefully have some questions that help make the big questions a little bit more focused. And what I really want to do is give you a sense of what we're talking about at the Mono Lake Committee, what we're looking at as the things we need to work on in the next 1 to 5 years to really get our arms around this for all of us who care about Mono Lake. So let's see what we've got here. Now the first question, or the panel here, the description, the first issue was how is Mono Lake doing after these warm and dry winters that we've had? And the answer, of course, you all know is not so good. I mean, it's a lot lower. That's so 2014, now 2015, some wonderful local students here, and not much of a change for 2016. It does create some problems that are a lot of the conversation that happens with visitors and folks here this this summer and so on. The land bridge out, extending now out almost all the way to Nedget Island, coyote predation out toward the gull nesting ground, something that we thought we'd never really be having to deal with again after winning protection for the lake and the lake plan to have the lake rise. We're even looking at fence routes for possible deployment in 2017 with the state park and Forest Service partners to protect those islands temporarily during the drought. And so you can see, I mean, these recent years here and the record drought that began in 2012, sure enough, the lake went down. Now this is not that surprising. Mono Lake's a salt lake. We all know salt lakes like to go up and they like to go down because they have no outlets and the water just leaves by evaporation. And certainly the history of Mono Lake has ups and downs, and this larger, longer history we'll look at, pre-diversion even, the lake fluctuated. So the current situation isn't, exactly, the sign of climate change. It may be just the drought, but it may be more than that. And we'll try and sort of pull those things apart here a little bit. Just to cover the basics, we're talking about the Mono Basin watershed. This photo's from the International Space Station. It's like my favorite presentation photo. It's pretty cool. Nice sunrise, you get to see all the watersheds. So, of course, we're talking about the Mono Basin watershed, which does extend out into Nevada, but the fundamental situation here at Mono Lake, and it makes it maybe a helpful place to think about climate change and talk about climate change, is it's kind of simple. We have a lot of snow up in the mountains. The snow does melt. It goes down the tributary streams, whether it's Levinon Creek or going down the Rush Creek drainage and into Mono Lake. And the lake is rising and falling with inflow and evaporation. We can go all the way back to the Mono Lake guidebook of 1980 here for the basics, and although lots of things have changed since then, the basic equation has not, right? So we have inflow from snow-fed Sierra streams. We have some other sources, springs and groundwater movement. We've got this inflow from precipitation, and then the lake loses water to evaporation during throughout the year. And we'll keep coming back to this. We'll kind of take a look at all of these major inputs and see what the climate change future has for us in store, or what it might have. yeah, so we'll get to that. Now, historically, thinking back tens of thousands of years, hundreds of thousands of years, Mono Lake has gone up and down a lot. There's no particular reason it has to be hanging around at the level we're all used to in our little short lifetimes here. So this is Lake Russell back at its maximum level, and where's Greg's talk? He's going to tell him how long ago was that?
Tahoe glaciation, maybe 150,000 years ago.
150,000 years ago. So much bigger. Thank you, Greg.
You're welcome.
And the lake has, that's really the maximum extent. It's been bigger, it's been smaller. Interestingly, it's never been as small in volume as it is now after the Los Angeles Aqueduct. And so this gives us an interesting perspective. We have natural variation in the past. We've also been performing, not by plan, but we've performed a vast climate experiment here at Mono Lake by simulating an epic drought for a very long period of time by constructing this giant piece of infrastructure, which has taken, of course, a lot of water away from the tributary streams and moved it south. And we all know the direct results of that. Mono Lake has gone down in a very classic way we're familiar with. And the lake level has gone down. Diversions began back in 1941. And you had the pre-diversion natural kind of fluctuation patterns, and they go much further back, and then this very steep and abrupt decline as the tributary streams are essentially shut down in terms of their inflow to Mono Lake. So going back to our basic formula here, right? That's an experiment where we took this inflow from snow-fed Sierra streams and cut almost all of it off. The lake went down a lot. It gives us a point of reference to think about, and one of the efforts here is to try and just sort of figure out what are the bookmarks, what are the possibilities in an era of climate change. So the diversions to Los Angeles, if you compare them to natural runoff, so this is our Rushley, Vining, Parker, and Walker Creek. So this is the unimpaired or undiverted runoff measured each year going back to 1940. And you can see the natural variation of that through wet and dry years with 100% line running right through there. So that's what's coming out of the mountains. Now, if you're Mono Lake and you're looking at this situation, it's more like this. So we took that whole part and sent it south, and these would actually fluctuate a little bit, but this is the average when you look at all of that drifting water. So we simulated about a 48% of average runoff conditions that ran for 4 decades here across this time period, and then now it's been returned to something more natural. So that is longer than any drought that has impacted the Sierra, and certainly in recent times, and it's really unmatched except by our friend 2015 last year, one of the driest years on record. So this experiment really runs at the very outer edge. I mean, if this was where climate change was going to take us in the next 50 years, a lot of things are going to be happening in California as we all abandon the state and head elsewhere. I mean, it's probably not foreseeable to have something that severe happen to the lake. And we know what happened. The lake went down. It would have gone down much farther, and it gives us a good bookend. So what we do with the lake level models that we can run at the Mono Lake Committee, and they're similar to the ones, or they're the same as the ones the Los Angeles Department of Water and Power has, because we use them to check their output, is we can kind of go back in time and see where the lake would be in different scenarios. So we know what happened with that artificial drought imposed, and then the years that followed as we won some protections for the lake. Here we are. We're at 6378 feet above sea level. That's the current lake elevation. So what if there hadn't been protection measures implemented? People hadn't spoken up. There was no Mono Lake Committee. There was no public trust decision, and those diversions had just continued at that running about 48% of average for the lake. You run through the model and you get about 6350, so 28 feet lower than it is today. So next time you're down there, the lake's looking low, which it is, and it's feeling a little sad because it does. To see it go down, just remember, 28 feet lower is where it could be if protection actions hadn't taken place. And this, not only is it lower, but it's far below the threshold at which the scientists who were here in 1976 said, wow, this lake's going to collapse. And all the subsequent studies verified that. You're looking at, say, brine shrimp productivity numbers of less than 1% of current numbers, for example. So that's really the ecosystem collapse scenario that was so concerning about the Mono Lake situation and that motivated the protection efforts. Okay, so we're not there. That's good. What about the other end of the spectrum? What if there just had never been any diversions? What if the aqueduct hadn't been constructed in the Mono Basin? You can take that very well measured runoff and put it into the lake level model and see where we would be. And we'd be up here at 6416, which is just about the same level that the lake was when the aqueduct gates were opened in 1941. So it gives you the range. The thing about this that's interesting is whatever's happening with climate, there's all kinds of signs of change, but from a Mono Lake perspective, at least today, the lake would not have fallen down to where we are. We're still seeing the current level compared to where it would have been without the aqueduct is really influenced by those large water exports to Los Angeles of years past. So we talk a lot about lake level. We measure the lake level a lot. It's the best and easiest way to kind of say how's Mono Lake doing and see what's going on out there. But when we talk about moving the lake level, and I want to maybe talk about this next question of, okay, so here we are, how are we going to get to the management level, the long-term management? Are we ever going to get to the long-term management level? It's useful to talk about the volume of the lake in this case. It's not that different looking of a graph than the lake level because they are connected directly. But you do take out the issues of the changing surface area and volume of the lake when you're talking about lake level. So you can see over here recent volumes for the lake, including the drought dropping us off. And this blue dashed line running across is the long-term management level that was set by the State Water Resources Control Board back in 1994. So that's where we're trying to get the lake for the long term. And our diversions begin here, same abrupt drop down. The difference between those is about 650,000 acre-feet of water, or a 25% increase in volume from the lake from where it is today to get to that long-term management level. That's a significant amount of water. It's definitely a significant amount on the east side. It's also not an unimaginably large amount of water. That's about how much water Los Angeles uses for the total water supply of the city in 1 year. And what we find when we look at the lake, and we look at the history, and we think about the possibility that maybe we're just stuck down here at these low lake levels and we can't get out of them, is it's a lot harder to raise the lake than it is to maintain the lake level. So to achieve that balance between inflow and evaporation is easier, even if there's some changing climate impacts on it. It's a lot easier than the going up part. And when you go back and look, the parts where the lake really rises, where you get a big bump in volume, so you exceed the evaporation and you leave a whole bunch of water in the lake to boost it up to the next level, are these really notably wet years. And when it happens, it's wet. And a lot of lake rise takes place. Whoops. So 1982-84, most famously, 280,000 acre-feet of water added to the lake. So, almost half of what we need to get up to the management level. If we had had a repeat of 1982-84 instead of a 4 or 5 year drought, we would be headed up in that direction. And it's possible that'll happen in the future. It's just maybe not going to be as frequent, or we might have to wait longer to get there. But the key is that you have these relatively short-term, significant wet year events that boost the lake up. So how likely are we to have those events in the future? We don't have all those answers. When you look at the statewide planning documents, and this is from the Department of Water Resources and thinking about climate change in California out through the end of the century, you can see one of the big themes here is diminishing snowpack in this year. And so historical range over here, and these are showing water content in the snowpack on April 1st. And it's not hard to see this diminishing situation as they project it out under two different scenarios, lower warming and higher warming. I guess this is one thing I wanted to mention at the beginning, but I'll just say now. When we talk about what's going to happen at Mono Lake in the future, we're talking about a lot of things that are difficult to plan for, or difficult to even understand for the future, but maybe the most important one is we don't really know how much warming there will be, and that's because there's still a great possibility for all of us to take action that makes a difference in what kind of scenarios we experience, how much carbon pollution accumulates from today into the future, and how much that affects future temperatures. So we have to look at various scenarios, and this group and Janet and everyone is working on 350.org, the big one, and 350 Mono, and all the efforts. All those make a big difference to what we actually look at when we start talking about 50, 75 years away at Mono Lake. So the strange thing at Mono Lake, and all of these scenarios are worrisome as we plan, but the strange thing is this is snowpack, but it's being driven by warmer temperatures. And so it's a measure of how much snow accumulates, and when it melts, that provides a lot of problems for planning water supply in California. From a very simple perspective, though, if you're Mono Lake and you're getting more rain and less snow in the winter, which is the kind of standard Sierra forecast, higher snow levels, more precipitation arriving as rain, less of it is arriving as snow, it's still going down the streams into the lake. We've got a lot of problems that causes for the streams, but it will accumulate in the lake, and so that water balance there has this input continuing. And what we found as we've been looking at these things is of the two inputs here and this loss due to evaporation, that may be the less worrisome of the three for Mono Lake, even though it's the biggest. The more significant one seems to be changing temperature forecasts. This again is a sort of statewide planning documents, and they put us all in Mono Lake, and they put us all into these big regions, but it's sort of a helpful reference. So we're seeing that the Sierra region, which is roughly where we are, this is observed temperature change. This is what's already happened. They're showing up to between 1 and 2 degrees of departure from the baseline temperature, looking back from 1949 to 2005. So warmer, and we've seen that a lot through this drought. It's been dry. We have wet and dry, but we've seen the warmth just persist, and it's probably the thing that is worrying is that it's going to persist even when we get these wet years that come back. They're going to be warm as well, and that's the big changing factor. The projection here on the statewide level, again for the Sierra region, is to maybe be up in the 4 to 5 degree Fahrenheit change in range on average. And that's what's really driving the switch from winter snow to winter rain. And it has a number of other effects as well. So let me maybe dive into a few Mono Basin pieces of that here. There's as soon as you start talking about these climate questions and you talk about Mono Lake, you go, great, well where's the study that tells us the answers? I mean, somebody must have modeled all this stuff, right? And it's really hard, it's really complicated, and most all of the work, and there's great work out there is done at these big scale levels. California, and even isolating California can be a challenge. And I think we're just at the edge of the ability to try and do any sort of computer modeling projecting at something as small as the Mono Basin watershed at all. So we have a limited number of studies, and you have to kind of consider about 4,000 different factors and variables that go into these things. But we do have one good one, and it that gives us some information at least to think about. It's called the effects of projected climate change on the Mono Basin. It was done by these folks here at the University of Santa Clara. And so they looked at the statewide projections. They tried to downscale this to the Mono Basin, see what it bring. They found something similar to what I was mentioning. That actual precipitation change was only a couple of percent in their 2040 or 2070, 2080 projections. So less about precipitation change, more about temperature change. And so they found that there would be 3 to 5 degrees of warming as you get to these later, on average, as you get to these later decades, 2050s and 2080s. So how does that play out for Mono Lake? I'll give you a couple of different places that we have impact. So this graph is from their paper, and this takes us over to the streams for a minute. The streams are going to show a lot of impacts at the same time that we see that on Mono Lake. They've got Levining Creek, they've got Rush Creek, and they're looking at the 2050s and 80s out here in the future. Black line is historical, or kind of what we're used to, for the pattern of stream flow throughout the course of the year. And it's just what you'd think, right? Not too much water in the streams in the wintertime because it's snowing a lot. And it accumulates and then the snow melts, and we get a nice big peak here, June, July, and the flow tapers off as the snow melts and we go back into a winter pattern. What they found was, what they projected, is due to the warmth, the flow, you get more of it earlier in the season. You get the peak coming earlier because snow is melting earlier, the snow that's up there. And then because more of it's arriving as rain and less as snow, you're not really hitting some of these higher peak numbers that we do today. In terms of restoring the Mono Basin streams and managing them, those are pretty significant changes. You can see the peak flow moving maybe back by a month even earlier over time. And those would be real management challenges for how stream restoration is accomplished and just basic protection of the stream resources we have. Okay, so we're back to our basic graph here. And okay, so we're going to go to that. So inflow, potentially not changing as much. Just to be clear, they're all on the worry list, right? we're trying to decide which do we worry about the most, which do you spend time investigating, as the first thing you look at here. Those warmer temperatures give us reason to worry about how the streams are managed for health. They also are something that makes you really think about this loss of lake water due to evaporation term. So far in the models, it hasn't really shown up. We don't have evidence that Mono Lake is evaporating a lot faster out there today than it was 10 years ago. But it really seems like the likely place that we're going to see those warmer temperatures kick in. And of course, if you have let's just assume we had the same amount of inflow, that would be nice. But if the lake's evaporating faster, we still have a dropping lake situation. So this would be an area that needs some further investigation. You can do experiments. It's not that hard to do them at these temperatures, or to figure out ways to index that to temperature change and make some projections. The other thing that we've found in looking back through the data that's kind of unexpected is this piece about inflow from precipitation. And most of Mono Lake's water supply is coming as snowpack up in the mountains. That's great, but there is this factor, it rains. It rains over the lake, it snows on the lake. We had a great storm last weekend. It got 3/4 of an inch. That makes a difference, especially when it's falling on the lake. It's much smaller than the snowmelt input, but it's where the records seem to show the biggest amount of change to date. So if you look at the measuring station at Cane Ranch for precipitation, in the past 30 years or so, about 75% of the prior 50. And when we've looked at there's been some concern the lake is rising more slowly than expected in recent years since the water board decision, and that has been kind of flagged as a potential culprit. And so that's something we have to watch more carefully. There's only one measuring station there, so you worry a little bit. Did a tree branch fall in there and no one noticed for a year? How precise is this? That wouldn't last probably for 20 years, but it's a little dangerous to hang your whole plan on one measuring station, but it seems to be a component of the water balance that could be making a big difference in the future. So just to try to kind of summarize some of these things, and then I'll talk about a few of the projects that are underway and maybe a hopeful thing or two. We're looking at warmer temperatures being a key factor, and the concerns that could come with that: increased lake evaporation, changing snowmelt timing affecting the streams, and reduced stream flow overall. I didn't mention that would be due to increased evaporation, evapotranspiration before the water actually makes it to the stream. And then this reduced east of the Sierra precipitation factor changes the balance of water from Mono Lake. That's another one that's higher in the list. Change in Sierra precipitation is the biggest contributor to inflow for the lake. That's important, but doesn't seem like it's in the forefront right now. I know we're in a drought, but it's going to fluctuate. And then the more rain, less snow change, which is huge for California, and will have stream impacts here in the Mono Basin for sure, maybe has fewer lake consequences because the water moves to the lake either way, and in terms of strictly how the lake sees it. Okay, so a few adaptation strategies, and all of this goes under the umbrella of we got to fix the bigger picture in terms of carbon pollution and changing climate. I mean, those are the huge factors, right? That's what has to happen. So when you're a regional group, when you're focused on Mono Lake, like the Mono Lake Committee, I mean, what can we do here at Mono Lake as these impacts that are already happening and will happen roll out? We've got some ideas to throw at you. There's plenty more, and I'd always welcome hearing from folks too, because I know many of you are working on these kind of issues. One is there's going to be a lot of management actions that just have to be done to deal with things, changing stream flow timing maybe, or building fences out on land bridges, what have you. And the Sierra is often underfunded and underrepresented in terms of California resource management planning. And we recently joined on with the Sierra Climate Adaptation and Mitigation Partnership. It's a project that's really focused on making sure the Sierra and the headwaters of most of the state's waters get a fair share of any climate planning the state's doing, and funding for projects as well, cap and trade funds that are being distributed. There's a tendency for those to go to the big cities, that's what the votes are. So you got to keep the Sierra in the mix and make sure that those funding things are available up here. We have this really unique situation that the State Water Board is going to look at why the lake management level that they have prescribed, that DUP has been trying to achieve by following the State Board's rules. There's no way that it can be achieved by 2020 unless we're all awash in water that we've never seen before. And so they have a predetermined plan to take a look at that situation and think of, their range of possibility includes doing nothing, but it's at least it's a moment when an agency would take a look at the situation and possibly adjust some of those rules work. I think for the committee, one of our goals is to keep working with Los Angeles to achieve their local water supply and water conservation goals. We know the aqueduct is a big factor in this equation, and we want to be sure LA is able to get the water it needs during changing climate, to be sure that Mono Lake is going to be able to get its water, and we aren't caught back in a tug-of-war between urban needs and the protection of Mono Lake. LA's got some fantastic goals on conservation and reclamation. This one is really notable on local water supply. There about 15% of the city's water comes from Los Angeles local sources right now. And they are actively working to get that to 50% by 2035. And the more, of course, that comes from local supply there, the less they have to import from other locations, us being one of them. There's some small things too. It's all a big puzzle, right? So there's these long-term, there's small ones. This is the air quality station out on the North Shore, looking back at the Sierra. It does a great job of monitoring air quality, very important. It measures the temperature. It does a lot of great things, but does not record precipitation currently. And I was talking about that precipitation measurement out over the lake and so on. So we've been working with the Great Basin Air Pollution Control District folks to add a station out there, and other places like that would be helpful in making us have the data we need to model things. And then I have never made a slide like this before. I see, is that Eileen back there? She might not forgive me for this one, I don't know. We've got the DDP diversion dam, and I said there might be some good news all in the same picture here. But the point of this slide is, and this was just about 3 days ago, by the way, this great flow coming down, is that these aqueduct facilities have been adapted because of the State Water Board ruling to manage and allow for stream flow, fisheries flows, protection of the streams, restoration of the streams. And so we have tools that we didn't used to have in the Mono Basin and that many other places in California don't. This giant gate right here can be lowered and raised, and you can control how much water goes down the stream, and you can control the timing of that, you can control how much sediment moves downstream, and if conditions are changing and it makes sense scientifically to do something a little differently in an era of changing climate, we've actually got something we can adjust and talk about changing how it's operated here. I've got an enthusiastic audience member coming. We also have, so just a couple more things to mention here. We've got a recent stream restoration agreement that is sort of the next phase of the State Water Board ruling, implementing new sets of flows for the streams to restore them. Assuming everyone will memorize all of these different components to them. The point of this is there are a lot, it's been carefully thought out in a science-based way to make the most of the water that's going down the streams. And in the process of reaching the agreement with Los Angeles to deliver all of these flows, which lets us do patterns much more like this dark line, big peak flows that mimic the natural hydrograph. But in the process of doing that, we set up a system within the Water Board order where the scientists who are the stream experts can actively manage the flow pattern during the course of the year. They don't have to go and get special approval. You don't have to pay a $5,000 permit fee. You don't have to spend 3 years with attorneys getting an adjustment. Now, I mean, there's limits. They can't just say, we'd like all the water. That division's already been made. But if it's a year like this and there's a plan for a peak flow, let's say 200 CFS like there is on Rush Creek right now, and it made more sense to deliver that 2 weeks earlier or 2 weeks later based on conditions or based on restoration needs, under the authority of the stream scientists, they could say, Los Angeles, let's schedule that, make it happen 2 weeks earlier, and it will just actually happen. A little bit procedural, I know, but on the west side, for example, they have problems like reservoir rules that have been written by Congress, and they were written decades ago, and they can't be changed easily at all. And guess what? They're releasing water when they want to be storing it. They're storing water when they're worried it's going to overtop. They can't adapt to the changing pattern of flow that comes with warmer temperatures. And then last and greatest, I think, is the State Water Board order itself. We've been looking, I haven't really found anywhere else that the protection of a resource like Mono Lake is linked so directly with the access to water rights like Los Angeles has to divert. And you guys are all Mono Lake fans, you all know how this works. Based on the lake level, the water exports for the year are determined in this formula. And what it means is that as the lake goes up and down, for whatever reason, be it changing climate, be it the drought, LA's ability to export water is also adjusted because the two are forever locked together. And so as we have a changing situation out here, maybe it's changing inflow, maybe the lake's just evaporating faster, maybe there's less precipitation east of the Sierra, whatever it is, LA's impact on that inflow is going to continually be adjusted based on where the lake is. And you're not going to find many places where resource protection and water exports are integrated together and locked together in that same way. And so we have a great foundation going forward with the State Board. So there you go. There's a little walk through some of the scary climate parts of things and a few of the optimistic ones. And I would be happy to take questions as well. And we're going to do that before the break and during the break as well, maybe.
Okay, I think everybody's kind of ready to get up and walk around a little. So Geoff and Kaylin will both be down here in the